All right, let's look at this example question number 53 on page 13 of the packet. Now we're only going to do C. I'm going to give a little hint on how to do B because you're going to need to know that in order to do the practice problem next. All right, so I have a balloon. It's going up at 5 meters per second. So it says a hot air balloonist rising vertically with a constant speed of 5 meters per second releases a sandbag at the instant the balloon is 40 meters above the ground. After it's released, the sandbag encounters no appreciable air drag. Okay, so that means it's in free fall. Good. And then it wants us to do part C. How fast is the bag moving when it strikes the ground? So we're going to find the velocity with which it strikes the ground, or right before, the instant right before it strikes the ground. All right. So the thing to note here is because this is moving up, when they release that bag is also moving at the same speed as the person that's holding it. And so the bag is originally going at 5 meters per second, so it's going to continue up for a little ways and then fall back down. Okay? And we want to know what is the velocity right here when it strikes the ground. Okay, so let's think about our problem types. So we have 1D motion, it's going straight up and then straight back down. I kind of drew it to the side so we could see it a little better here. So I know to list my variables. As soon as that bag is released, there's no appreciable air drag, so it's in free fall. So my acceleration is negative 9.8 meters per second squared. And I'm just following the green sheet here. I'm asking about which type of problems do I have. Is it a max height problem? Nope, neither of our points is at a maximum height. Does it start and end at the same height? Nope. All right, so let's start figuring some stuff out. So they don't tell me where height is 0, so I get to choose it. So I'm going to choose it down here at the ground. I'm going to say this height here is 0. And it's 40 meters above when it's released. So that means it starts at a height of 40 meters and ends at a height of 0 meters. And originally it was released at 5 meters per second. So it was moving upward, so positive 5 meters per second. So next I want to find this final velocity, the velocity with which it gets to the ground. So I want to pick an equation without time. Okay, so pick an equation without time. That is equation number 3. Okay, so I have v squared equals v naught squared plus 2a y minus y naught. And now we just go through and we cross anything off that's 0. So the only thing that's 0 here is our final height. All right, and we're solving for v, so I just have to take the square root. And when we do that square root, remember we have to put the plus or minus on it. So it'll be plus or minus the square root of v naught squared plus 2a times, I have a negative y naught in there. All right, which is it going to be, plus or minus? So as it's going down, oh, that just told it to me. Going down, the velocity is going to be negative at that point. So here my velocity is going to be negative the square root of the initial velocity squared, so 5 squared plus 2 times negative 9.8 times negative, and then my initial height, which was 40. Plug this in your calculator, you should end up with something like negative 28.4 meters per second. So it's moving pretty fast when it strikes the ground. Do not throw sandbags out of hot air balloons. That could really wreck something down below. Now, part B wanted us to find time. And I kind of want to talk about this because it fits in with this plus minus here. There was 2 solutions for a velocity function here. Why were there 2 solutions? Well, if I think about it mathematically, okay, if I complete this parabola, if you will, you'll notice that at this point, it would be leaving the ground. At this point, it reaches the ground. And so here, it's moving at the negative 28.4. If I had imagined this not being here, it could have been a y naught equals y problem, and it would have left the ground at 28.4. So when we go to find the time, okay, the time it takes to go from here to here, it's going to have us set up a quadratic. So we're going to imagine we didn't solve part C before we solve part B, right? So we have a quadratic. So let's write out that quadratic quick. So I have, oops, we're in the y direction. So y equals y naught plus v naught t plus 1/2 at squared, and we'll cross anything out that's 0, so our final height is 0. So I have 0 is equal to 40 plus 5t plus 1/2 times negative 9.8t squared. So I have a quadratic which we can plug into polysymbol 2, and there should be 2 times. We want the time that goes forward, the positive time. Mathematically, there's actually going to be a negative time when that parabola reaches the ground again. And so let's go ahead, we'll throw that in polysymbol quick, and we'll see what those 2 times are, and we'll make sure we get the positive one. So let's go ahead and flip over to that.
All right, let's plug this formula into polysymbols. So we got to go to apps. Again, we got to scroll all the way down to P. Once we get down to P, we're going to pick polysymbol. And we have to hit enter a few times. We are going to be doing a second order, just like we did before. We got to hit graph to hit next. And we just got to fill in our information. So here I have the 0.5 times negative 9.8. And then I have, for my second term, it's a 5. We started out at 5 meters per second in the positive direction. And our final term is 40, because we started at 40 meters above the ground. We can click solve, and it should give us 2 times. One of them is the positive time. That's the one it hits the ground with. The negative 2 time, again, is that backwards time when it would have maybe started at the ground had it sent. It's been lifted off the ground and thrown up.
All right, so we have a time of t equals 3.4 seconds. Again, we want that positive version. So that'll hopefully help you out on this next practice problem coming up.